This learning objective is all about the constant sum, difference, and countable multiple rules, so just our rules for derivatives. And just knowing that you kind of break a derivative up over addition signs, subtraction signs, you can pull out constant multiples, that type of thing. So for this one, h prime of x, we can do keep the 5 separate and then take the derivative of the f part. We can keep the minus 4 separate and take derivative of the g part. Do the power rule, and derivative of a constant is 0. So this is going to be h prime of x. We're just breaking up the full problem into little problems, and then we want to plug in 1. So we plug in 1. We can use the information given to us to help us. All right, so it's going to be 5 times 2 minus 4 times 6 plus 6, 10 minus 24 plus 6, negative 12 plus 6, oh sorry, negative 14 plus 6 is negative 8. Just knowing that you can use these rules that are listed at the top to break up this derivative into smaller pieces and use the information given to you to solve it. All right, 22, same idea. This would be a hard derivative to do all at once, but I can do the derivative of 2x cubed is going to be 6x squared. Derivative of cosine is negative sine, so it's going to be plus sine of x. And then I want to plug in pi, so f prime of pi, 6 times pi squared plus sine of pi. So really it comes down to knowing what, at this point, what sine of pi is. But pi is the half circle, so I'm over here. Sine is y value, so sine of pi is 0, which gives me A as my right answer. At 23, h of x equals f of x plus g of x, so that means h prime of x. Using the sum rule, it's just f prime plus g prime. But what is f prime? Well, f prime, we know for a line, is just a slope. So we just have to figure out the slope of this line. That looks like a nice point. That looks like a nice point. That's up 1 over 2, which is 1/2. G, both of these look like nice points. Just down 1 over 1 is negative 1. And 1/2 plus negative 1 is negative 1/2. All right, this one, determine k from the following information. So everything's about derivatives, so chances are I'm going to have to take a derivative. All right, k is just some constant, so the constants stay. And then f prime of x minus 5g prime of x. And if I plug in my x value of 4, and for all these x's, I can use this table to my advantage. All right, h prime of 4 is 10. I don't know k yet, but g prime of 4 is 1/2. And, f prime of 4 is 1/2. G prime of 4 is negative 5. All right, so now I just have to solve this equation. All right, subtract 25 to the other side. Then multiply by 2 to get negative 30. All right, so that's going to be my k value. Basically just knowing that k is a constant, so I don't have to do anything when I take the derivative. It just kind of hangs out. And then knowing I can split up this derivative into smaller pieces, plug those values in, and solve for k. All right, our last learning objective for this unit test is about the cosine, sine, and exponentials and logarithms derivatives, which we did in class. This first one doesn't look connected at all. But if you think about what the limit, whenever you see this, you're thinking about the limit definition of the derivative. All right, so whenever you see that h approaches 0 part, think about that limit definition of the derivative. What is this one going to be? This is going to be, well, there's nothing being added to h, so I could think about that as 0 plus h. Minus, I want to copy the same thing. And this fits because 0 plus h is h. E to the 0 is 1. All right, so this is the same as the derivative at 0 for our original function, which the original function was e to the x. It's just kind of a really roundabout way of saying, okay, well, this is a limit definition for the derivative of e to the x. We know from what we learned the derivative of e to the x is e to the x. And then I plug in 0, and I get 1. All right, so this one is 1. It'd be pretty difficult to figure out any other way, just using kind of properties of limits and stuff. But if you recognize this is a limit definition of derivative for e to the x, and that you're plugging in 0, you can do it that way. All right, this is a pretty difficult problem, because you're kind of having to think about it in a roundabout kind of way. All right, 26, we have f of x. We want to find f prime of 0. So the first thing is finding f prime of x. All right, the derivative of cosine is negative sine, and the derivative of e to the x is itself. All right, so the constant stays, and then we just get e to the x. Oh, I also got this wrong. Should be sine. And now I want to plug in 0. Sine, unit circle, 0 angle, y value there is 0, so all of this is just 0. E to the 0 is 1, is 3. So our final answer is 3. Last one, same idea. F prime of x is going to be negative sine of x. They're going to plug in pi over 3. And this is kind of just memorization for the unit circle, remembering that sine of pi over 3. All right, pi over 3 is the 60-degree angle, the one that's kind of going more up, so the y value is bigger. It should be 3 halves, square root of 3 over 2. But we have that extra negative sign, gives me a as my final answer. All right, so this one just kind of requires you to know your unit circle in order to get the final answer. And last one, we have this big function. We want to find f prime. Again, you can break it up into the smaller pieces. Derivative of cosine is negative sine. The negative 3 is going to stay, and the derivative of sine is cosine. The 4 is going to stay, and the derivative of e to the x is e to the x. The negative 8 is going to stay, and the derivative of natural log is 1 over x. So you can just leave it like that. You could also combine this last part to negative 8 over x if you wanted to. All right, but that's our final answer for this one. You're basically just taking 4 individual derivatives, remembering constant multiples. So these are just going to stay. And you're just taking the derivatives of the individual pieces. So cosine turns into negative sine. Sine turns into cosine. E to the x turns into e to the x. And natural log turns into 1 over x. All right, so you're just doing each piece separately using our known derivatives and our derivative rules. All right, so that's our entire Unit 3 practice test. Again, go through and kind of figure out what you know, what you don't know. The real test is going to be similar problems with, slight differences. Maybe I put cosine or sine here instead of cosine, or a different number. Maybe this one has a natural log in it instead of an exponential. But those types of things, knowing how to do all these problems will help you know how to do all the problems that are going to be on the actual Unit 3 test.